All right, so section 6.1 is about simplifying roots. So like square roots, cube roots, they want us to simplify that type of stuff. And then eventually we're going to get into some of the stuff with variables. Okay, but before we do that, let's kind of talk about some of the things you should know. Okay, so you should know that the square root of 1 is 1. Okay, the square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. The square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Okay, those are pretty normal. Okay, most people know those already. 81, the square root of 81 is 9. The square root of 100 is 10. And usually that's as far as they'll take you in elementary school. They don't normally try to push you too much further. Middle school, sometimes they get you up to your 12. So they'll do the square root of 121. That's 11. Or square root of 144, which would be 12. Okay? And at that point, most teachers kind of stop because it is true, 12 is pretty much as high as they ever take you in square roots up until you get to like maybe trig and calculus. You might see some other stuff, but here it's about 12. Okay? Now there's a couple more you should know. The square root of 169 is 13. The square root of 196 is 14. Square root of 225 is 15, and the square root of 256 is 16. So those are good for you guys to kind of know. You should know those square roots because those are common. Okay, those are common square roots. Now, cubed roots, there's not as many as you have to know. Okay, but there are some that are kind of useful. Okay, so common cubed roots. Well, the cubed root of 1. Remember, in order for something to be a cubed root, the number has to occur 3 times, right? 1 times 1 times 1. That would be 1. So the cubed root of 1 is 1. The cubed root of 8, that's 2. Because 2 times 2 times 2 is 8. Okay, cubed root of 27, that's 3. 3 times 3 is 9 times 3 is 27. So cubed root of 27, that's 3. The cubed root of 64, that's 4. Okay, because 4 times 4 is 16. 16 times 4 is 64. And the last one that I would probably recommend you guys know, after that I guess you can have calculators do some stuff for you, but the cubed root of 125. It's usually as big as they go, unless they expect you to use calculators to figure stuff out. But not everybody's calculators can do these things, so you kind of have to know some of the basics. So those are cubed roots, the common cubed roots. Okay, so cubed root of 1, cubed root of 8, cubed root of 27, of 64, and 125. Those are 1, 2, 3, 4, 5 respectively. So just kind of keep those with you when you're doing the homework so that you can kind of say, okay, I got to think of what numbers become the following thing, and then you start looking at your square roots or cube root values and use those. Okay, so that's pretty much all we're doing with numbers. Now, when it comes to letters, and then we're going to get to the examples. So these are just the numerical cube roots and square roots. Roots with variables. When you're doing roots with variables, you have to make sure the power on the variable matches the index. Now, first off, let me explain what that is, right? I don't know if you guys all remember what that means, but so normally a root looks like this. just that you don't always see that little I term. If you don't see the I term, that means that I equals 2. So the I is called the index. Whoops, sorry about that. So the I is called the index. N is the power. And X is the radicand. And obviously the little symbol is your radical. Right? So if the index isn't there, then I equals 2. So just a real quick note right here. If I isn't there, then I equals 2. In other words, it's going to be a square root, a number of 2. Just like we say x squared is a 2. If the I is a 2, we use a square root. Okay? If I is 3, that means it's a cubed root. If I is 4, it's a fourth root. Okay? But the index is important for us to know. The reason is because when you're doing roots with variables, you got to make sure your variables match the index. Okay? So this is what I mean when I say that your variables match the index. So if I do this, the square root of n to the 5th, my index is a 2 because it's not there. So if it's not there, it's a 2. Now notice my index and my power, they don't match. I got to make them match. So what I'm going to do is I'm going to break this apart. Okay? I'm going to leave that little index right there. Instead of n to the 5th, I'm going to write n squared, n. That's n to the 5th. If you want, you can write n to the 1st. N squared, n. That's 2 plus 2 plus 1, right? That's 5. Now, if your index matches your power, then you can take out that letter. So that means I can actually take out this n and that n. I can take them out. And that's going to give me n squared, because there's n times n on the outside. Or you know what? Let me write n times n. Let me not skip anything here for now. Square root of whatever's left over, well, just n to the 1st. N times n is n squared. Square root of n. Notice I got rid of the index now. I didn't write it out. Okay? But I got rid of it. So that's how you simplify variables. Okay? So if I were to write cubed root of x to the 5th, then I got to break it down into powers of 3. So cubed root, x to the 5th is x to the 3rd x squared. X to the 3rd x squared. 3 plus 2 is 5, right? So the powers match, 5 and 5. But since my index matches this power right here, I can take out that x. So this becomes x cubed root of x squared. Now sometimes people will tell me, what about the x squared? Well, there's no way for me to break up a power of 2 so that I get 3 of them, right? Right now there's 2 x's. I need 3 of them to make a cube. So I can't just like magically put in an extra one. So this would be my answer for this one right here. So at the end of your homework, we're going to be doing stuff like this. Okay, towards the end. At first, we're just going to be dealing with numbers. But towards the end, you're going to be given numbers and letters. And you got to pay attention to that index. Okay? If there's a number in front of the radical, if it's a 3, then okay, it's cubed root. That means you're looking for things that have powers of 3 in terms of variables. Okay? If it doesn't have an index, that means it has to be a 2. And you can write it yourself. A lot of my students will do that. Just kind of write a little 2 there as a reminder of what they have to find. But You'll see how it goes right now. So we're going to start off with the beginning of the homework, how it's going to look at the very beginning, okay? So we're going to do a couple of examples here and then we'll move on. So here we go. So we're just going to simplify. So let's try this one right here. The square root of 200. Notice we're not going with the easy stuff like square root of 9. Like we should know that already. Let's try doing stuff that's a little bit more interesting here. So obviously I do not have a square root of 200. Okay? There's nothing that I listed that has a 200. There's a 225, there's a 196, but not a 200. So what I have to do is break up this 200 into two numbers. One of those two numbers should have a square root attached to it, a nice square root. So how can I write the number 200 as two numbers multiplied together? Any two numbers you want, but one of them should have a square root to them. What's the easiest two numbers you can use that multiply to 200? Two times 100, right? Does 2 have a square root? You can look at that list. Is there a square root of 2? No. Is there a square root of 100? Yeah, what's the square root of 100? 10. So this gets to come out as a 10 square root of 2. And there you go. That one's done. Okay, I could have used 50 times 4. I could have used 25 times 8. Just that those would result in more work eventually. Okay, and let me show you what I mean by that. So if I would have used 25 times 8. Well, does 25 has a square root? Yeah, what about 8? No, right? But I can take out the 25. That's going to give me a 5 square root of 8. Now the question is, can I continue breaking down 8 into two numbers? Yeah, right? What times what is 8? 4 times 2, 2 times 4, either way. Does 4 have a square root? Yeah, it does. What is it? 2. And the square root of 2 doesn't exist, so we're not worried about that. So it's 5 times 2, square root of 2. Remember, the reason why a 2 comes out is because that's what the square root of 4 is. Square root of 4 is 2. 5 times 2 is 10, square root of 2. Now notice this answer matches the one that we had before. The only difference is the amount of work, right? So it's not like there's only one right answer. You can pick any number to break stuff down by. But if you're able to pick the best number, the biggest number to break it down by that has a square root, then that's going to make things easier on you. So 2 times 100 was perfect because 100 has a square root and 2 does not, so we're done right away. But you could have picked 25 times 8. You could have picked 50 times 4. Okay, there's other options you could have done, and you still would have gotten the same answer, just maybe more work. So before you just kind of start and just go right at it, think, okay, what numbers can divide 200? And try to go big first, okay, as big as possible. And if you're wondering what numbers you should try, the numbers you should try are these right here. The ones inside these square roots, so like this stuff right here, this stuff right here. Try those. Okay, see if the numbers can be divided by any one of those, an 81, 64, a 49, a 36. Go big, because if you go big and you find one, that means your work's going to get easier. Because most of the numbers that are even can be divided by 2. But maybe they can be divided by 100 or 121, right? So you want to check those, because that's just going to make your life a little easier. All right, so that's one of them. Let's do another one. Now, these are considered some of the easier ones because they don't have any letters or anything like that. So let's try the cubed root of 56. So for cubed root, I'm looking for something that can divide 56 that has a nice cubed root. So look at the cubed roots that I gave you. I think I gave you only 5 of them, right? What number divides 56 that has a cubed root? An 8, right? 8 times 7 is 56. So I can rewrite this as the cubed root of 8 times 7. And 8 has a nice cubed root. It's a 2. 2 cubed root of 7. Does 7 have a cubed root? No. So I'm done. We'll do one more of these, and we're going to move over to some of the tougher ones. But these are supposed to be kind of like the easier ones. Because like I said, they don't have any variables or anything like that. So let's try the square root of 128. So obviously you don't want to try to divide 128 by 256. That's too big. But go with numbers smaller than 128. Okay? So what's a big number that can divide 128 that has a nice square root? So look at your list. I mean, what's smaller than 128 that has a square root? 121. Can 128 be divided by 121? No. After that's 100. Can 128 be divided by 100? No. After that would be 81. Can you divide 128 by 81? No, you can't. 9, 8. Can you divide 128 by 64? Yeah, you can. It's 64 times 2. Oops. So this is a square root of 64 times 2. Which one of these has a nice square root? 64. So if we bring it out, it's going to become an 8. Square root of 2. Does 2 have a square root? No, so you're done. Now, I'd have had students that tell me, well, Mr. V, can't I just like plug that into my calculator? Yeah, you can, but I want to see the work. Okay? You can just type this into a computer, right? That's the reason why I made this a multiple choice for you guys, because I figure, well, if you're working at it by hand, at least you can look to see, are you on the right track, right? Am I kind of working on this the right way? So that's why I made it multiple choice. So these are, like I said, some of the easier problems. After that, they start to give you some with letters. Okay? So let me give you some of those. This is going to be example number 2. We're just going to simplify still. We're not changing any of the rules, still applying everything that we've been doing, trying to find square roots, cubed roots, etc. So let me give you one that looks like this. Now this one starts off kind of easy, but it's just sometimes confusing to some people. So I want to make sure we go over something like this. So the square root of 28k. Now whenever I see letters and numbers inside of radicals or roots or square roots or cube roots, I always start with the number first. So what two numbers multiply to 28, but one of them should have a nice square root? So again, this is where calculator kind of helps, right? Like you're like 2 times this, 3 times that, 4 times that. Anybody know what times what is 28? 4 and 7, and 4 has a nice square root. Now, the letter. What's my index for this thing? The number in front of the square root, what is it? a 2 because we don't see it, right? It's a 2. That means that my variable needs to have a square power. But right now, it's just k to the first. It's too small. I can't break it up. So I'm just going to leave it. Nothing's going to happen to that k. There's no way for me to take it out because I need a power of 2, but it's at a power of 1. It's below the power of 2. I can't just make it a power of 2. That means I'd have to like introduce another k. I can't do that. Now, if it was k to the 5th, I can break it down. But this one I can't. This is the reason why I'm doing this problem with you guys, just to show you sometimes the letters, you can't take them out. They may be there, but you may not be able to take them out. So let's continue. I know that 4 has a nice square root, so that's going to become a 2 square root of 7k, and this is your answer, because there is no square root to 7. You can't break down 7 into a multiple of 2 numbers, so there you go. Well, a 7 and a 1, but we're not looking for 1s. We always look for 2s, 3s, 4s, 5s, stuff like that. So again, these are considered a little tougher because they have letters, but we didn't really do anything with the letter, right? So let's try doing something with the letter. Part B. Oops. So slowly getting a little bit tougher here. 2 square root of 45 m squared n. Even though it looks worse, just do what I told you. Deal with the number inside the square root first, then the letter second, and we should be fine. What's the index on this problem right here? A 2. Okay, so let me make sure I write that out. 2 square root, and I do that just for the purposes of the variables, okay? For the variables. Let me actually write that in green here just to make it stand out just a little bit more. All right, 2 numbers that multiply to 45. One of them should be a nice square root. 5 and 9. All right, so 5 times 9. 9 has the square root, 5 does not. And then m squared. Notice m squared has a matching power. So that's perfect. And then n, well, n has a power of 1. I can't make it any bigger, so that's just going to stay there. The m, though, is going to leave. Okay? The 9 will go out and become a 3. The m squared will come out and just become an m. So this is what I have. 2 times 3 times m. I'm getting rid of the index now. And all that's left over is what on the inside? A 5n, right? That's it. That's all that's there. So now just multiply the outside. 2 times 3 is 6 times m is m, so it's 6m. Let me put this a little lower here. 6m square root of 5n. And that's my answer. Now I'm going to do one more that's considered a pretty tough one, okay? But I'm doing this one because it has something that's a little odd to see inside of a square root or a cube root, shall I say. Are we okay with part B? So again, breaking numbers down into things that have square roots, that's the key. Powers are usually pretty easy. You're just saying, okay, well, this power, it's going to be power of 3 because that's what my index is, or a power of 2 because that's what my index is. So let me show you this one. This is going to be our last one. Part C. 7 cubed root of negative 625 a to the 8th. Now, if you're seeing that negative inside of that radical and you're thinking, wait a minute, that doesn't make any sense. Cubed roots, any odd index can have negatives inside, okay? So I'm going to write that down for you guys right here. Any odd index, so a power of an index of 3, 5, 7, 9, 11, 13, right? Any odd index can have a negative number inside, okay? It can have negatives inside the radical. So that's okay. So just to give you an example, the cubed root of negative 8 is negative 2. Okay, the cubed root of negative 8 is negative 2 because negative 2 times negative 2 is positive 4 times negative 2 is negative 8. That's what's inside of the cubed root. So negative numbers inside of odd indices is normal. Okay, the answer would just be negative. Okay, so if you see a negative number inside of the radical for a cubed root, the answer would just come out with negatives. So I know that this answer for C should have a negative there. Okay, so now the next thing is 625. That's a big number. This is 7 cubed root. All right. What times what is 625, but I want to use my cubed roots. Remember, I have 5 options. Right? I have a cubed root of 1, a cubed root of 8, a cubed root of 27, a cubed root of 64, and a cubed root of 125. Which one of those 5 should I try? 125, 64, 27, 8, or 1? What did I tell you guys to start with? Don't you always start with the biggest numbers, right? So try 125 first. Can you divide 625 by 125? Okay, I see some of you guys saying yes. 125 times what? And you can always use your calculator, right? But it's 125 times 5. Okay, so this is what I'm going to write. Negative 125 times 5. Now the reason why I left the negative on the 125 is because that one has the cubed root, so I wanted that negative to go out with it. Okay? Now I got to break down a to the 8th into what powers? What powers do I want for a to the 8th so that I can take them out? Yeah, 3s. Right? I want 3s. Because they have to match the index. So this is going to be, let's see, a to the 3rd times a to the 3rd, that's 6, times a to the 2nd, that's 8. So let me highlight the index with those powers that are going to come out. So 2 a's are going to come out. The a squared is going to stay, it has no choice. The 5 is going to stay, that has no choice. This negative 125 is definitely going to come out. It's going to become a negative what? What's the cubed root of 125? 5, right? So it's going to be a negative 5. So here we go. 7 times negative 5 times a cubed root of 5a squared. Oh, by the way, I didn't draw these, but this should have come out. This should have come out as well. I know I said it, I forgot to show it. So 7 times negative 5 times a times the cubed root of 5a squared, because that's all that's left over. There's no cubed root of 5, and I can't take out an a squared. The power is too small. So my answer, negative 35 a squared cubed root of 5a squared. That's my final answer to this one. So in your homework, you guys will be doing stuff like this. There's a couple, 1, 2, 3 of them that are pretty big numbers. We just did one. There's another one here that's 750. There's another one that's 875. So just try those out. Always try the bigger numbers. So 125 first, then try 64, 27, etc. All right. So let me give you guys the homework. You can use a calculator. I'll bring them out in case you guys want to use them.